Okay, this is kind of a weird problem. This is supposed to be the Earth. I've rotated it a little bit from the picture that's given in the book, and says that we have this mountain that has an elevation of 1,530 feet. If you're up here at the peak of the mountain, and it shows, I didn't draw this, but you can actually see the rays from the sun quicker than somebody that would be down here. So if this is a person, basically what we're doing is we're going to see how long before, as the Earth is rotating, you get there, that person would actually see the rays of the sun. So how much longer afterwards? Well, the first thing we need to figure out, and let's say that this is D, is if I know this is the radius, I need that little piece right there to be able to kind of do this outer circle. So I can do that by finding this P, make sure I'm still on screen, this PD piece by taking my elevation, which notice this is in feet, and I'm going to convert it to miles. I know that 1 mile is 5280 feet, so of course my feet cancel, and I get 0.29 of a mile. Okay, so that part's done. Well, that means that this radius of this outer one would be 2710, so my radius, 2710 miles plus the 0.29. So now you kind of see why I converted that, because I wanted to add 1,530 feet to my miles. So I have that so nicely converted, I have this radius. Now, because this is moving, I'm interested in finding this angle here in radians, and I can see what's kind of nice is because I know my X value and now I know my R, if I have X over R, remember that's cosine. So that's why I'm going to use the cosine function. So here I just simply plug in everything I have, my X value, I just found my R value, and that will give me my angle in this case in radians, 0.01463, and that's my actual angle that I care about. Well, from here, this is moving, right? So I'm going to know what this arc is, the length of the arc. Remember that, S equals, let's do it right here, S equals R theta. Nice little formula to remember. And so we know in this case, if I'm on this inside one, I'm back to my radius, the R being 2710, and I just found my angle, 0.01463, and that gives me, in this case, 39.64, still on camera, and that's in miles, because of course this was in miles. So that gives me that nice little arc length as this is moving. Well, they gave me a hint, and they said use the fact that latitude in 24 hours, okay, is 2 pi times the radius. All right, so that fact was given to me. So what I'm going to end up doing, besides getting a different pen, is I'm going to solve this for time. And so I'm going to end up with this fact here. Once again, this is information that they gave me, 2 pi 2710, the latitude in 24 hours. Well, I'm going to set this equal to this 3964, and that's what I'm solving for, right? The time that it takes, as this is rotating down, for that person now to see the sun rays. So all I have to do is do a bunch of cross multiplying stuff and solve for t. So the t comes up here, this flips, all that nice good stuff, and I get 0.0559. This is in hours. We don't really talk like that, so it might be nice to multiply this by 60, and you'll see it's about 3.35 minutes, okay, that this person here in 3.35 minutes will be down here and see the rays of the sun. So lots of pieces here, but definitely drawing it out, seeing that certainly I need this angle to be able to get this length right here, okay, so that tells me how many miles that is, and then I can use this to be able to solve for my time.